Hello students, welcome to today's lectures on AGM 311, Introduction to Farm Mechanization, Study Section 3. The title of today's topic is Internal Combustion Engine. Introduction. An internal combustion engine is a heat engine where the combustion of fuel occurs with an oxidizer in a combustion chamber that is an integral part of the working fluid flow circuit. In an internal combustion engine, the expansion of high temperature and high pressure gases produced by the combustion applies direct force to some components of the engine, thereby transforming the chemical energy into useful mechanical energy. In this study section, you will be familiar with the description of internal combustion engine and other operational cycle. Learning outcome for study section 3. On completion of this study section, you should be able to describe internal combustion engine and external combustion engines, define certain terms associated with engines, describe all the cycles of operation in a four-stroke engine, that is diesel or petrol. Principle of internal combustion engine. Combustion means the burning of fuel in the presence of air or oxygen. Internal combustion engine involves the burning of fuel in a confined system for the generation of heat energy and the liberation of mechanical energy. Examples of fuels are kerosene, diesel, and petrol. Examples of internal combustion engines are motor cars, motorcycles, tractors, generator. We also have the external combustion engine. In external combustion engines, the combustion of fuel takes place. In external combustion engine, the combustion takes place outside the closed confinement, such engines are railway engine. We have the steam traction engine. We have the gas turbine engine. There are two basic types of internal combustion commonly used on the farm, and they are the petrol engines and diesel engines. In petrol engines, a spark ignition is used, which is produced by a spark plug, and in diesel engines, a compression ignition engine with the with the use of pressure is used. Both engines operates in their power by burning the liquid fuel inside the engine. Then the next thing we are going to be talking about is the terms used in engine, the terms associated with engines. To be able to understand the difference between the spark ignition and the compression ignition engine, there is need to know and be familiar with some terms commonly used with the engine. The first term we are going to be talking about is the clearance volume. The clearance volume is the space above the piston within the cylinder. Next is the top dead center. Top dead center is the position of the crank and piston when the piston is farther away from the crankshaft. While moving upward, the piston cannot go beyond the top dead center. Next is the bottom dead center. Bottom dead center is the position of the crank and the piston when the piston is nearest to the crankshaft. The piston cannot move down beyond the bottom dead center while going upward. Then another terms that need to be associated with an engine is a bore. Bore represents the internal diameter of the cylinder. We also have the stroke, which is the distance between the top dead center and the bottom dead center. We also have the swept volume, which is the volume of the space between the top dead center and the bottom dead center. It's also called piston displacement. We also have the engine capacity, which is the swept volume of all the cylinders, and lastly we have the engine size, which is given by the bore, which is the diameter of the cylinder, and the stroke of the engine. Cycles of operation. The moment an internal combustion engine starts working, it operates in either of two ways. We have the two-stroke cycle. In two-stroke cycles, the power stroke takes place in every revolution of the crank. In other words, the crankshaft makes one revolution and the piston makes 2 strokes in each cycle. Then we also have the 4-stroke cycle. In 4-stroke cycle, the power stroke occurs in every other revolution of the crank. This translates to the crankshaft making 2 complete revolutions, and the pistons make 4 strokes. Here, a stroke is the movement of the piston from one end of the cylinder to the other. Principle of a 4-stroke petrol engine. The images on the slide shows the various activities that occurs in the petrol engine. So the first of those activities is the intake strokes, as shown on the image on the first image on the left side of the slide. In the intake stroke, the inlet valve is opened to allow the mixture of air and fuel to enter the vacuum in the cylinder. At this point, the piston is pushed downwards from the top dead center to the bottom dead center. It could be noted that the outlet valve remain closed. Then the second image to the left shows the compression stroke in the petrol engine. In this stroke, both the inlet and exhaust valves remain closed. The piston is pushed upward by the connecting rod to compress the fuel-air mixture in the combustion chamber, thus increasing the temperature of the mixture. Then the next series of events that took place in the 4-stroke petrol engine is the power stroke. With the approach of piston towards the top dead center in the second stroke, the mixture of fuel-air mix is ignited with a spark arising from the spark plug, causing them to burn. The resulting expanded gases pushed piston from the top dead center to the bottom dead center. At the same time, both the inlet and the exhaust valve remain closed. The last event that occurs in the 4-stroke petrol engine is the exhaust strokes. In the exhaust stroke, the crankshaft pushes the connecting rod upward, which in turn moves the piston upward from the bottom dead center to the top dead center. In this process, the product of combustion is pushed out of the cylinder through the open exhaust valve to the cylinder. It is to be noted that the inlet valve remains closed during the 4th stroke. The cycle or series of events continues so long as the engine keeps operating. Then next we are going to be looking at the principle of 4-stroke diesel engine. The 4 strokes obtained in petrol engine are obtainable too in diesel engine. That is intake or induction stroke. We have the compression stroke, power stroke, and the exhaust stroke. The major difference lies in the way the diesel fuel is burned. In the intake stroke, the valve opens while the exhaust valve remains closed. Air only is supplied into the combustion chamber, forcing the piston downwards. Then in the compression stroke, the piston moves from the bottom dead center to top dead center, thus compressing the already admitted air in the combustion chamber, thereby increasing the temperature as a result of the compression. At this point, both the inlet and the exhaust valves remain closed. Then we have the power stroke. Immediately the compression is ended, atomized or fine spray of diesel fuel is injected into the already heated compressed air, resulting spontaneously into burning, which pushes the piston downwards. For the power stroke, both the inlet and the exhaust valves remain closed. The direct delivery of diesel fuel into the combustion chamber is accompanied by the injector. Then lastly, we have the exhaust stroke. The exhaust strokes, in the exhaust stroke, the piston moves upward to push out the product of combustion through the exhaust valve that is now open. The inlet valve remains closed during the exhaust valve. Thank you for listening.